Let us try to solve another problem. Let us have now SELE MST Board Exam Problem number 9. Allow me to read our problem in this session. A stone is dropped down a well, and 5 seconds later, the sounds of the splash is heard. If the velocity of the sound is 1,120 feet per second, or 341.376 meters per second, what is the depth of the well? In this particular scenario or situation, we have to consider two times. First, the time of the stone travel, considering free-falling body, and the time sound travel, considering uniform motion. The time the stone travel plus the time the sound travel is actually equal to 5 seconds. For the time the stone travel under free-falling body, we have to consider or use the second kinematic equation, and it is h equals to 1 half gt squared. But since we are calculating for the stone travel, the time the stone travels t is equal to square root of 2h over g, based from the second kinematic equation, or derived from the second kinematic equation. Our second kinematic equation is equal to h equals to 1 half gt squared. Originally, this formula is equal to y equals to bot plus 1 half gt squared. But since the initial velocity here is 0, then we have to cancel out bot. That's why our formula is h equals to 1 half gt squared. And in order to calculate for the time, we have to transform the second kinematic equation into this formula. T is equal to the square root of 2h over g. And now let's proceed for the time the sound travel under uniform motion concept. In this situation, we will adopt the formula h equals to bt. Since we're looking for the value of the time the sound travel, we will be adopting this t is equals to h over b. And now, by summing up the time the stone travel and the time sound travel, which is equal to 5, we will be adopting this formula now. By substitution process, we can obtain this formula. Square root of 2h over g plus h over b is equal to 5. And take note of this for your information. The value of g is constant, and that is equal to 9.81 meter per second squared. While the velocity is actually given, we have the value for the velocity in metric system as 341.376 meter per second. And now, we can do now the direct substitution from the formula square root of 2h over g plus h over b is equal to 5. Finally, we have now our working equation as square root of 2h over 9.81 plus h over 341.376, which is equal to 5. Finally, we can now perform our calculation using Canon F789 SGA by applying the shift calc strategy. Finally, the answer to the unknown value of the depth of the well is equal to 107.64 meters. But still we have to check for this value by checking for the time. Let us now solve and check for the time. By substitution process, using the formula for the time, the stone travel, t is equal to the square root of 2h over t, now equal to square root of 2 times 107.64 all over 9.81. Our final answer is 4.68 seconds, and as we can see that it is less than 5 seconds. Therefore, the result is okay. And of course, we also have to check for the time the sound travels. We have it as 107.64 divided by 341.376, and we have obtained a result of 0.32 seconds. Finally, for the last part of our checking, the time the stone travels and the time the sound travels must be equal to 5 seconds if we're going to add them. As we can see now, we have 4.68 plus 0.32. Their sum is equal to 5 seconds. Definitely, our answer for the depth of the well, h equals to 107.64 meters, is really correct. Thank you very much and God bless us all.